Oh, hey, it's me, Mr. Summers, the best part of Armstrong High School, walking you through this lab about how to do energy in food. And we're going to go through some general stuff first, set up independent, dependent variable, and controlled variables, and then we'll go from there into running the actual lab for all of you who can't be here or have some sort of nut allergy. So let's start this process up with the setup. Here it is. It looks a little like this. What we're trying to do, there's a thermometer here inside of a cup. We're going to put some water in that cup, and then we are going to burn some sort of chemical, in this case a marshmallow, which will represent the carbohydrate group, or a cashew, which will represent the lipid group. And we're going to see how much heat will go from that marshmallow to the water we'll put into that can, and then the amount of heat will be measured by how much temperature changes in the water inside the can. And that is relatively what the whole lab is about. Let's take a second to go through our variables, right? In our lab, we have three things we're looking for. There it is, right there, independent, dependent, and controlled variables. Look, that's backwards. Good luck on reading that one. First, our independent variable is going to be what's different between each time we run the experiment. So the first time we run the experiment, we're using a marshmallow. The second time we run the experiment, we're using a cashew. So our independent variable happens to be the type of food. Dependent responding variable is what we actually are measuring. In this case, it's temperature, and we're going to use that temperature to try to find energy. So you can put either one of those down because they're roughly the same thing for this one, but our dependent variable happens to be temperature. Controlled things, hopefully we'll be able to use the same amount of water both times. Hopefully we'll keep the same distance, the same temperature in this classroom. Hopefully we'll have one match, we can keep that consistent. All of the regular things that you normally have as your dependent variable are still your dependent variable, or sorry, your controlled variables are still your controlled variables. Distance, water, temperature, the normal ones you've put down. At this point in time, you should also look at your sheet and come up with some sort of hypothesis of which one you believe is going to have more energy in it. Do you think that the marshmallow is going to have more energy in it, or do you think that the cashew is going to have more energy in it? All right, take a second. We'll start this process up. First thing on your data table, table 1, right there. Look, you can see that through this camera. No, you can't. Data table 1 says A, mass of empty can in grams. So this is our can right here. Put it on this balance right there. It says 24.39 grams. 24.39 grams. That is our mass of empty can. 24.39 grams. Next thing it says, put in 50 milliliters of water. So here it is, 50 milliliters of water going into our empty can. And we need to find the mass of that also. That says 72.88 grams. 72.88 grams. Write that one down. Next one down on our list is the initial temperature of the water. Our initial temperature of the water happens to be 22.3 degrees Celsius. 22.3 degrees Celsius. We're going to skip the one that says final temperature of water. That'll be done when we are done with the actual lab. But we have to look at the mass of the food plus the holder. The reason why you need the mass of the food plus the holder, because when you burn just this, it's most likely going to stick to this wire mesh. So if we know mass of the food plus the holder, we can be able to measure it both times because we don't have to scrape it all off this wire stuff. So let's put it on the balance. Mass of food plus holder says 20.18 grams. 20.18 grams. Alright, so here we go. It's time to burn some food, right? So we've got the marshmallow about an inch, maybe a little less away. Thermometer's still in there. We're going to use that to stir while this is going on. We know the amount of water. We know the temperature of that water. It's still 22.3 degrees Celsius. I'm going to try to do this with one match. That is our goal here, is to stay consistent with the amount of energy we're putting in, because if you do use more than one match, you can kind of lose, gain some energy because you've got more than one match going on. There's heat coming from that onto our little calorimetry meter. And we'll just burn that marshmallow and see how much the temperature rises as the marshmallow burns. While we're doing this, at the bottom of that data table it says qualitative observations while burning. This would be a good time to make a qualitative observation because we're burning it. Trying to get as much of the marshmallow on fire as I can so that the temperature should change on us a little bit. It's really burning towards the back side. You can see it really well there. But that's a marshmallow on fire, squad. It's on. Killing it right now. Just killing it. Alright, our final temperature, 36.0 degrees Celsius. You should write that down. Final temperature of water, 36.0 degrees Celsius. If you want to make some observations about how much the marshmallow burned, there it is. Look, the whole thing. Yeah. I'm so good at sciencing. Look at that whole marshmallow burn. The one last bit of data we need for the marshmallow is the final mass of marshmallow and holder, and that happens to be 19.35 grams. 19.35 grams. We start this whole one up again. We have to restart by doing the same things we did before. So now we need to find the mass of the empty can. The can is 24.82 grams this time. That's different than the last time, so make sure you write that down in your data table, 24.82 grams. Second thing we need is the mass of the can plus 50 milliliters of water. So here's 50 milliliters of water. We'll dump it into the can just like we did before, right? Trying to stay consistent with the amount we're keeping on here. Get the mass of that one. Has to be 75.30 grams. Another thing, trying to stay consistent, we're using now, again, our temperature for our water. Our initial temperature happens to be 22.2 degrees Celsius. 22.2 degrees. Skipping over that final temperature of water because we haven't burned it yet, we do need to find the initial temperature of our cashew plus our holder. So here we go, cashew plus holder. Initial mass of cashew plus holder is 17.0 grams. 17.0 grams. Alright, it's time to light this one, right? We have hopefully kept everything consistent. We have the same amount of water. We have a different food. We have the same distance. I'm going to try to start it with one match, just like the other one. Cashews normally don't go up as easy, so we'll see what we can do here, but here we go. Qualitatively, right now, you could probably put that Mr. Summers took at least 2 matches to start this one up. That is different. That's a spot of error. You can use that in your conclusion. It is tougher to get the cashew to light on fire than it is the marshmallow. my gosh, it's going to take 3 matches. That's not the match. Oh, we're so close. There you go. That cashew is on fire. Now we just sit back and enjoy the show. Riveting, isn't it? Just a burning cashew. Good times. Seriously, still going. Alright, you can see it's still smoking, but when that thing finally actually stopped burning, we got a 40-degree final temperature, 40.0 degrees Celsius. You can also make some observations on how much of it burned, right? Oh yeah, look, not all of it. Might a lot of it got combusted, but not all. And our final mass of Food Plus holder is 16.22 grams. 16.22 grams. That concludes everything you need for this experiment. After this, you should be able to go through the part that says processing the data. When you're processing the data, all of it tells you where it came from in your data table, which I've attached a picture of, so that you can be able to use that for your lab. That's pretty much it. Nice job. Way to have an allergy or to be absent. Miss school, we miss out.